Good morning everybody and welcome to today's webinar. Today we're going to be looking at some of the recent changes to guidance and guidelines that the government has published, some of the recent changes to legislation that affects us, and I'll be picking out the most important parts of that I see that are going to drive change within our industry. I'll also be trying to put this into perspective for you. Rather than look at the details of these changes and the specifics and just giving a summary of the changes, which many people have already done so far, I'll be trying to pick out maybe some of the issues that, when in combination, are going to make a big impact on us and the choices we make in our careers. As a business owner and as an engineer, one of the worst things that you could possibly imagine is turning on the TV screen and seeing an image like this. A number of years ago, I was running a business and we had a serious accident in one of our factories, and I swore at that point that nobody would die in a factory that I ran. When the Grenfell Tower fire happened, I extended that principle to nobody would die in a fire due to a product or a system that I'd supplied either. Possibly equally terrifying for a professional is the prospect of being faced with an individual like this, the amazing Richard Millett, who's been the lead QC in the Grenfell Tower inquiry. No doubt the questions that you've seen Richard Millett put to the witnesses in the inquiry have made you think yourself about the choices that we make and how we might want to avoid being in that situation ourselves. So why have I chosen to put this webinar together now? I've been quite active on social media over the past few years, commenting on the inquiry as it's gone along and so on, and the various changes to regulations and guidance. But we're at a juncture now where I felt it was wise to bring together a number of issues and a number of changes that make sense. So now is a good time to actually look at all these changes, because the consultation results have now been embedded into approved document B. There looks like there will be more to come in the future, but they could be some years off, and so now it seems to be a good time to take stock of what changes have been, because although the changes in the future might be a number of years away, I think we need to look at actually changing our attitudes and behaviour now, something that Dame Judith Hackett has encouraged for a number of years, but really we can't wait to see what the future changes are going to be. And why should you listen to me on this topic? Well, Ashton Lacey is a well-known supplier of rain screen and ventilated envelope systems in the market. I've been running this business now for over 10 years and seen a lot of changes within the industry from a manufacturer's perspective as well as a client's perspective and so on. And I have to get my head around an awful lot of changes within this industry, the various challenges of running a complicated business. We supply to the aerospace industry, the automotive industry, as well as the construction sector. And I have to deal with the changes with product regulations and requirements, classifications and so on, as well as deal with HR issues, finance issues, marketing, every other aspect of running a business. So it's my job to try to take lots of complicated things going on at once and present a coherent strategy for the business and make a simple message throughout a complicated situation. I've been a chartered engineer for nearly 25 years now, fellow of the Institution of Mechanical Engineers for 20 years. At the time of the Grenfell fire, I was the chairman of the technical committee of the Metal Cladding and Roofing Manufacturers Association, and by virtue of that, I was brought in to be the independent expert to look at the large-scale testing program that government did shortly after Grenfell fire. So I've got a lot of experience of what happened after the fire, briefing ministers, MPs and so on. I've seen a lot of the thinking that's been going on. I'm also on the British Standards Institution Committee for large-scale fire testing, BS 8414 and so on. So we're going to look at a number of different aspects that all form together to be a big challenge for our industry moving forward. We're going to look at the Fire Safety Act of 2021. We're going to look at the much more complicated Building Safety Act, which came into effect this year. We're also going to look at some of the changes in approved document B and the regulations that have come in conjunction with this. I'm going to try and identify some of the flaws, inconsistencies and problems with those documents that might give you a heads up on some of the issues we might foresee in the future. And I'll be trying to put this into context against a background of changing information, emerging dangers and knowledge of various things going on, perhaps in the wider field that you're not so familiar with. And most importantly of all, what I'll be trying to do is make sense of all this in terms of where this is all heading and how we should all respond to it. So the Fire Safety Act implications are fairly straightforward. They clarify that the external wall and the structure of the building of anything that has more than 2 dwellings in it is part of the fire risk assessment that must be carried out on a regular basis. Now that's a big change moving forward, because this applies to buildings of all heights, including those that maybe didn't have any restrictions whatsoever when they were built. So instead of a building being deemed to be compliant at one snapshot in time, this is going to be regularly assessed against a backdrop of emerging knowledge and changing perceptions moving forward, and that's going to create a significant problem. And as I've said, one of the major issues with this is that many of these buildings under 18 metres historically have been built with no restrictions whatsoever on the materials that you can put on the external walls. But recent fires that have happened over the last few years, particularly those since Grenfell, have comprised materials other than ACM cladding and so on that are very commonly found in such low-rise buildings. Now, the common perception may be now that these don't meet the functional requirement of the building regulations. That in itself might create numerous problems and a never-ending supply of buildings which need to be remediated. What this is going to highlight more than anything is the difference in risk perception between the insurance and mortgage sector and that of the building regulations and their desire to protect life, health and safety and so on. When you look at a high-rise building such as this one on the left, you can see that there's very good alignment and correlation between the resilience of that building that's required to provide a safe means of escape for the people in that building. That building has to be resilient to afford you sufficient time to get out or be rescued from the top of it. That's in stark contrast, of course, with a low-rise building such as this, where you can virtually build it out of anything you want, and the chances are you're probably still going to get out alive. So from a building regulations point of view, they both still give you adequate time to get out of the building and therefore are deemed to be compliant. However, the recent fires over the last few years have shown that actually a building might give you enough time to get out alive at low rise, but it might be absolutely useless as a piece of collateral for a mortgage, or it's not uninsurable in the sense that it's going to burn down to the ground despite the fact that everybody has survived. Now, the Building Safety Act, however, is a completely different proposition, and there is a multitude of secondary legislation that is going to cascade from this document over the next few years, some of which are going to have major impacts on how we go about our jobs on a day-to-day basis. What I'm going to try to do over the next half an hour, 40 minutes, is pick out a few of these which I think are the most serious, and also how they perhaps combine to work together to make life even more difficult. So the Building Safety Act predominantly applies to high-risk residential buildings or high-rise residential buildings. So buildings over 18 metres and 7 stories. I'm not going to go into detail today about the leaseholder protections, but they apply above 11 metres. And this has been one of the main mechanisms that the government has introduced under Michael Gove for recovering the costs of building dangerous buildings from the developers and the freeholders to try and protect leaseholders from being a cash machine to pay for these remediations. The Building Safety Act also establishes the Health and Safety Executive as the regulator for this part of the industry, and establishes the clear duty holder roles for the client, the principal designers, the principal contractors and the specialists. It also introduces various gateways, safety cases and completion certificate requirements, which we're already seeing start to make an impact on the way we go about designing buildings. And it also sets out the competency requirements for each part of designing a high-risk residential building. The Building Safety Act also defines the need to establish a golden thread during the construction and design process, and it makes amendments to the Defective Premises Act, which historically, retrospectively, will result in a 30-year liability period for external wall materials, which will become 15 years moving forward. In addition to that, we have the notion of a building liability order, which is also being created. So if a manufacturer or a designer has supplied a material during the construction which it is misrepresented or is fundamentally inherently defective, then the judge has the ability to actually apportion the responsibility and the liability for that to that party, even if they weren't contractually involved in the construction of that building. That is a potentially scary situation when you take it in conjunction with the removal of the corporate veil. So even if you had a limited liability division, regional division or subdivision of a parent company, a PLC and so on, this combination means that basically there's no protection from the parent company of a PLC if a division has acted in a way that is deemed to be inherently dangerous, liable, they've misled the public and so on, or the designers, they can be held liable as an entity. So just very briefly, a few observations on some of these things. Competency requirements. Now, competency is a huge challenge and there's lots of debate within the industry about whether competency can even be actually defined. One of the biggest challenges we have in the design of complicated buildings is that potentially one individual cannot possibly have all of the competency required to cover all the aspects of that building. So it might be actually very difficult, if not impossible, to define competency. The one thing I would say though is that there's one thing above all other things that a professional should know, when approaching a project like this, and that is that they should know their limits. And that is one of the fundamental principles, for instance, of being a chartered engineer, is that knowing when you're out of your depth, you have to say, look, we're going to have to bring somebody else in to do this. So knowing the boundaries of your skill set and your capabilities is one of the key things that this part of the whole process needs to establish. The Act also sets out the requirements for establishing a golden thread and the responsibility on the client and the developer to build a golden thread of information of all the materials and systems that went into building the building, so that if there's a problem later on in its life, a record is available showing exactly what went into these buildings. A lot of the buildings have been remediated over the past few years. It's been impossible to tell what the actual materials are. Now, there are huge problems associated with this, and at the moment my concern is that this is a burdensome, onerous obligation on designers and suppliers and manufacturers and so on, which necessarily isn't a problem, but the problem I see at the moment is that you could potentially build up that digital twin or golden thread and so on, but when you went to interrogate it because you wanted to find out some property of a material later in the day, you might actually find that that wasn't part of the digital protocol for digitizing that product, and the information isn't even there. Changes to approved document B. I'm not going to go through all of these and summarize them, but I'm going to pick out a few which will highlight the problems that we still have with a document which has been criticized ever since the Lakanal coroner's inquest. One of the continual criticisms of approved document B is its complexity and its confusion and so on, and you would think that after the Grenfell Tower inquiry criticisms, we would have got to a position where we would have started to rationalise the document, simplify it, and make it clearer and easier to understand. I'm just going to pick out a few things which I think will show that we're not really heading in the right direction yet. One of the more positive aspects of the changes in approved document B is the changes in scope. So we've mopped up things like hospitals and schools now into the requirements, and we've introduced, crucially, some restrictions now on the materials that can be used on buildings under 18 metres and even under 11 metres if it's less than 1 metre apart from the next building. What approved document B also attempts to do, and is backed up by a regulation change as well, is introduce a complete ban on ACM material with an unmodified polyethylene core. And I'm going to quickly look at whether that actually achieves its aim. So the restrictions introduced under 18 metres are slightly different in the nature to the combustible ban of over 18 metres, in that it's only the insulation and the cladding itself under 18 metres which now have requirements. That allows us to use light timber frame and modular building and so on, so we can pursue the sequestration ambitions of architects using timber frame. Whereas with buildings over 18 metres, the only way to use mass timber and so on, cross-laminated timber, would be to use a building like this, which has got basically a timber frame with an oversailing or infill external wall made of non-combustible materials, A2S1D0. So it was largely the fires after Grenfell that prompted the changes under 18 metres, including significantly this fire in Barking. This fire at Barking Riverside in 2019 prompted the attached letter to be issued from DCLG. And Francis Kirwan basically said, well, we know that the guidance says that you can build buildings under 18 metres without any limitations on the external walls, but we didn't really mean it. What we basically mean is that you've still got to comply with the functional regulations which require you to adequately resist the spread of fire. Clearly in this case, it didn't do that, despite the fact that it was a couple of cats and a bit of a scorched resident that jumped off one of the balconies. Again, this fire wasn't a fatal fire, but it was clearly a very near miss. To give you an idea why we desperately need restrictions on all buildings, this video, taken in Baku in 2015, shows you the real potential that exists with extremely dangerous external wall materials. Amazingly, in this fire nobody died, but unfortunately a few weeks later there was another fire with a similar cladding system, and I think 16 people died in this fire. It's very difficult to get information about these fires sometimes, but in this situation it wasn't an ACM material, it was a polyurethane based cladding system that had been built off the building using a framework that created a chimney effect and a large space between the cladding and the structure itself. So I think it's universally accepted that what is commonly perceived to be the most dangerous material that we know of, which is polyethylene cored ACM, should be banned for all buildings across the board, regardless of the use or their height. So let's have a quick look and see whether they've managed to achieve that. What the government has done is it's introduced effectively a completely new classification standard for one material aimed at eliminating polyethylene ACM. And the way that it's done that is by setting a limit to the combustibility and the total heat of combustion of the core material of a composite sandwich panel, and it set that limit at 35 megajoules per kilogram. So what we effectively have here is a classification of barely limited combustibility. It's still a combustible material, but they've set a limit which is just below what the worst material possibly could be. What we don't do is cater for multiple non-substantial layers. So what I'm going to do is look at whether that ban, in the way that it's worded, is actually going to achieve what it was intended to. So there's quite a lot of information on this slide. On the right-hand side, you have a list of commonly available polymers and their total heats of combustion. What we're trying to do is we're trying to create an ACM material with a core of less than 35 megajoules per kilogram. And it's fairly straightforward to do that, given the rules that we've been set out. The equation that I've drafted that gives a suggestion of how you can decide, depending on which material you want to mix to dilute the polyethylene. It tells you what thickness effectively or by volume that material will occupy. So I've given a couple of examples here, for instance. The first one, mixing PTFE, which is a very low combustibility material, in with the polyethylene. And it turns out that you need about 13% of polyethylene by volume to get the total heat of combustion of that core material below 35 megajoules. You could actually just mix sand in with it or some other inert material. The ironic thing here as well is that if you actually mix a material to dilute a polymer, that material will be called filler material. It's the only area of engineering which actually has a formal definition for filler material in the polymer science. So that works against what the government is still trying to do with Approved Document B, which is create a definition for filler material which doesn't exist anywhere else. Potentially even worse than that, a designer would actually have the ability to increase the thickness of that core material. So we don't actually install cladding by the kilogram, we install it by the meter squared. So if you actually went from 4 millimeters to 6 millimeters, for instance, potentially you could increase the amount of fuel content that you're attaching to that building by 50%, but yet that would still be allowed given the wording of how they've tried to draft this ban. So we have poor terminology still remaining within Approved Document B. We've got a brand new classification standard which isn't approved by any international standards organisation whatsoever, and it's still possible to actually fix a polyethylene material or something extremely similar, potentially even with more energy than was on the Grenfell Tower. What I would also point out is that some of the restrictions introduced below 18 metres relate to the allowance of using Class B materials. But Class B and below within 13501, those classification standards and the tests used to classify them also have inherent problems, very similar to what we've seen with Class 0 in the Grenfell Tower inquiry. The classification tests are too low powered to break down a composite material where you have two layers of non-combustible material outside of something highly combustible. And I'm pretty confident that I could genuinely get polyethylene ACM as it was used on Grenfell Tower, bona fide classification Class B, S1D0. And the way to do it is with a machine like this. What this machine is doing is it's routering the edge of the ACM sheet material to create a space allowing the roll forming element of this machine to fold over the aluminium edges, and it will totally encapsulate the polyethylene. So in the low power tests in 13501, which are 13823, which is the single burning item test, and 11925, which is the ignitability test, the polyethylene isn't actually exposed to the flame at all. So in addition to the problems with 13501 that remain for products of Class B and below, a brand new classification standard to deal with banning ACM, we also have exceptions that still exist within Approved Document B, which in my view have no justification whatsoever. And the two notable ones are we still allow 200 micron coated steel and we still allow 9mm timber in certain situations. The problem with the 200 micron coated steel is that actually this material does seem to burn quite nicely, and generally speaking a product such as HPS 200 will have a classification of C, but there's no justification that this should have an exception. And in fact the Kew Travelodge fire showed that this material potentially, there's no confirmation that this actually used HPS 200 or something similar, but given the composite panel nature of this building it's highly likely that that was the case. As you saw before with the fire in Baku, it's very difficult sometimes with fires of this speed to actually capture these on film. But the evidence we have suggests that actually it was purely luck that the fenestration of the Travelodge allowed the fire to go up the side of this building very quickly without spreading it through the building. 9mm timber, allowing that is a relic of research that was done after the war. And what that showed was that if you had 9mm timber or timber between windows, it didn't really affect the rate at which fires rolled over from one to the other. But it's a mistake to then extrapolate that thinking into the fact that 9mm timber isn't a problem, because what they didn't seem to think was that 9mm timber or timber cladding itself could be a mechanism itself for external fire spread. So that's basically a mistake which should have been rectified many years ago. If 9mm timber is classified to 13501, it comes out as D, it shouldn't be allowed. The changes also allow BR135 classification to be a route to compliance between 11 and 18 metres. I think given the criticism that's come from BR135 through the Grenfell inquiry, I think there should be a moratorium on using that as a route to compliance. It would avoid situations like this, where you see in this video, this is a material and a system that got a positive BR135 classification, but any fire engineer watching this video probably wouldn't use this system where a high degree of resilience was required, because all the tiles basically fall off and you can hear them crashing down onto the floor as you watch the video. And it's highly likely, as I'll speak about in a minute, that the classification standards that come out of BS 8414 testing will be significantly different in the future, and I'll talk about the work stream that's looking at that later on. One of the points I've made on many occasions is that the notoriously complex approved document B, a large degree of this complexity and confusion arises purely because of the determination to allow combustible materials to be used. If you simply said, we're going to use A2S1D0 materials above 11 metres, then essentially a large part of approved document B relating to external wall provisions collapses into one simple requirement. So approved document B, in my view, is still in a mess. We have classifications of B and below, which could be considered unlimited combustibility, with significant problems with their tests. And I don't think that there's any plan to actually look at the suitability of these tests themselves, unless the large-scale testing program actually supersedes it. They've had to create a totally new classification, which really undermines the confidence in 13501, the fact that that classification standard can't prohibit the use of ACM. And the reason for that is that encapsulated combustible materials, composite materials, and thermoplastics, they are particularly good at sneaking around the classifications and the tests. And in my view, the only robust and reliable classification standards within 13501 that you can genuinely rely on are the A classes, A1 and A2. They are the only ones, in my view, that stand up to scrutiny, because there's nowhere to hide for the combustible material. They're disassembled into their constituent elements and assessed in their own right. Filler material, once again, terminology is really important, and it will never mean what the government is trying to make it mean, even trying to rewrite history and so on. Filler material is not just material that fills in spaces. It is a material that's added to a polymer. A robust classification standard is what we all want, and if we got it, we wouldn't have any exceptions to it. And BR135, in my view, should be totally suspended as a means to compliance, subject to the ADB technical review. So what's happening with the approved document B technical review? Now, there are 10 work streams going on at the moment. Some are more important than others. Some are big projects, some are fairly small projects. But the 4, I think, will have the most impact on where we go, and possibly the most retrospective impact as well, are the following that you see here. I'm particularly interested in workstream 8, which is looking at large-scale testing and reaction to fire testing standards and classification. But I also think the smoke and toxicity project will be of significant importance. And to be honest, if it doesn't in itself, as we'll come on to in a minute, I think other smoke and toxicity issues will overwhelm that. Property protection is another major issue. As I've described before, there's almost an irreconcilable misalignment between the building regulations requirements and their approach to risk, and the approach to risk of insurers and mortgage providers. And I think unless they align or they agree to differ and have a different approach to things, then the fire risk assessment that was aimed at assessing the life safety of building is not going to be an acceptable basis of risk assessment for the mortgage and insurance providers. So they're going to have to do their own assessments to a different standard and a different set of guidelines to PAS 9980. At the moment, there is enormous pressure to improve the sustainability of the buildings that we design and we build. Timber frame, to many, is seen as a silver bullet to the carbon problem and global warming, sequestering carbon into the structures that we build on a daily basis. Whatever material you do choose to use, my philosophy is that you should use as little of it as possible. From my personal perspective, I think that the mass timber argument is more of an insurance issue than potentially a life issue. My personal passion is about avoiding rapid one-off catastrophic events, because it's the speed that I think that is the biggest threat to life. But there's no industry consensus on these issues. You've got the concrete industry fighting with the timber industry, fighting with the steel industry, and so on, and everybody has different opinions on which is the best approach to go. Industry disagreement on which is the best material to choose is exacerbated by the lack of consistency when it comes to generating environmental product declarations and BIM standards and so on. So it's very difficult to make a like-for-like comparison at the moment. So I think we've got several years left of refining these standards so that we can make a fair comparison, and more studies need to be made of the life cycle and the circularity of these materials before we can make sensible decisions. But a major point of what I want to get across today is that it's not just about fire. And in fact, I think that with everything going on in the wider scientific community, actually fire may become the least of our concerns when it comes to choosing materials without fear of retribution and retrospective changes going forward. I would draw your attention to one thing, something that I'm consistently going on about, which is Regulation 8. Now, the tendency for everybody you talk to, particularly within government, is that Approved Document B is all about life safety. But if you actually read the words of Regulation 8, you will see that it's not just about life safety. In fact, those words don't even exist in Regulation 8 and what Approved Document B is trying to achieve. It is aiming to secure reasonable standards of health and safety, not just getting out alive, of the persons in and about the buildings and any others that may be affected. So that includes firefighters, people who are downstream of fires, having to close their windows. Even if you get out alive and you've come out of the building with a great lungful of toxic smoke and so on, and it's compromised your life expectancy, you've clearly been impacted by the materials that that building was made out of, and it's affected your health and safety. So, and it's not just your physical health and safety as well, also your mental health. And if you talk to the 4 or 5 million people that are trapped in combustible flats that they can't sell at the moment, it's had a devastating impact on their mental health. So your personal interpretation of Regulation 8 may be something that you might have to rely on one day. I particularly wanted to focus on innovative materials and their dangers and what they mean today. Because as we've seen in the Grenfell Inquiry, one of the consistent themes is that regulations don't keep up with the pace of the development of modern materials. There is actually a European framework for funding research into suspected dangerous materials, and there are regular calls for papers and submissions to fund materials that hopefully will prevent the next asbestos, thalidomide and so on. So there's no limitation to the field of application of these research papers and research topics, and when you actually start looking into these, you start to realize that the dangers of modern materials go far beyond potentially how they perform in a fire. So at this point, in the spirit of knowing your limits, I'm going to declare myself totally incompetent here. However, this is a very important subject, and I do know somebody very close to me, and this is my wife on the left, who knows a lot about the biological impacts of materials that we use in the construction industry. She's a level 2 approved pathogen expert and a genetic immunologist, and she works at the Cambridge Department of Pharmacology and Toxicology. And she's introduced me to some of her colleagues that are working on certain projects which I think are of great interest to everybody choosing materials for building and construction. So there's an awful lot going on beyond fire with materials and chemicals and toxicity. So in 2017, the EU published a report on fire toxicity, which concluded that actually there was no need to regulate it. But that's not really surprising, given that there was no agreement amongst the panel members, several of whom were representatives of the chemicals and plastics industry. But enough is enough in terms of some chemicals and materials. Recently, there's been much change in the regulation of these materials, and particularly things like forever chemicals, PFAs and so on. And there's a noticeable, discernible change in the attitude of major governments to these materials that are used widespread in the manufacture of paints, clothing, construction materials, plastics, polymers and so on. And it's not just chemical toxicity which is the issue. Certainly when it comes to a lot of the materials that we use in construction, fibers and particles, so that don't even have to be combustible or a polymer. Fibers and particles, as we know from things like asbestos, have the potential to cause cancer, mesothelioma, and there is much research going on to this at the moment. So if you're faced at 10 years' time with a QC who's saying, well, weren't you aware of all the dangers of this? This was in the news, this was on mainstream television, this was clearly published research. Well, there's nowhere to hide from the fact that at the moment news stories prevail about the dangers of these materials. People are looking into nanotube reinforcement of materials, graphene, the potential to cross the blood-brain barrier. This is all fairly scary stuff, of course, and all this information is out there already. This was a story that appeared fairly recently which caught my eye. Manchester, the home of graphene, where it was discovered in 2004. Recently the home to a new ice rink where they've used graphene reinforced concrete. Now this really caught my eye because in the story you can see the Graphene Research Centre actually has air extraction units, they've got goggles on, they've got PPE and so on. But as you can see from the video here of the poor installers of this material, they don't benefit from the same protections. And this is scarily reminiscent of the early days of materials like asbestos, where the dangers were completely unknown at the time, and these tragic images now of individuals working with this material who probably shorten their life expectancies by 20 or 30 years or so. And it's not just things that are reminiscent of things like asbestos that are potentially a problem. We've all been very aware of plastic pollution of the sea, microplastics and so on, that we think mostly comes from rubber tires on electric vehicles or washing your polyester clothes too much and so on. But the materials that we use in the construction industry also have the potential to produce large amounts of microplastics. A few years ago, I went down to Travis Perkins and bought myself, it's the only time I've ever done it, a metre squared of phenolic foam insulation. As you can see from this video, just cutting 1 metre of this material produces quite a large quantity of very fine dust, various dimensions. I estimated that even in the UK alone, in 1 year, the dust produced from cutting this material being installed in buildings would be several lorry loads full of this microplastic dust, which is just basically lost into our environment. Now, when I released this video on social media a few years ago, lots of people said, well, people don't do that, they use vacuum saws and so on. Well, very handily for this presentation, just a couple of weeks ago, somebody posted the following photograph, which very nicely summarizes the problem. Installers installing this material, there's dust, there's particles everywhere, they're not wearing any masks, they're not wearing eye protection. Okay, you're not going to get poked out in the eye by a piece of foam plastic, but your mucous membranes and so on are your protection layer for these types of particles. That's how the body has evolved to deal with these types of materials, and that's your defense mechanism. And of course, on the right, you see another way of ingesting these microplastics. You go from installing these products, pick up your sandwiches, all of a sudden you've got microplastics being absorbed into your bloodstream through your stomach linings and so on. So why is that such a big problem? This is an image which makes me particularly sad. It's something that the Americans seem to have a tradition of doing. When a family has a new baby into a firefighting family, they tend to take a photograph of the baby with the firefighter in full PPE. This now seems highly inadvisable. We know that these chemicals, the products of combustion from plastics and building materials and so on in particular, they can travel through your skin from the dirty overalls and so on. So only recently, firefighting has been classified as a carcinogenic profession, and we're learning more and more about these materials, these chemicals, every day that passes. Perhaps a more familiar example is smoking and the damage it can do to a mother's baby as well as herself, but also not just the baby. The baby's reproductive organs, eggs and so on can also be damaged, which could mean that the baby's baby, so 3 generations worth of damage to DNA and cells. Perhaps even more terrifying than that is that epigenetic damage to our DNA could be passed on throughout the generations and create irreversible damage. What we're basically saying is that the materials that we're surrounding ourselves with today could be altering the entire course of biological evolution forever. So what does that mean for us? Obviously this is very difficult for non-biologists and so on to get our heads around, but it does give us an indication of what we should be thinking when we're choosing materials for our project. For me, one of the first things that's obvious when you're comparing materials is the material man-made? Is it a recent introduction into our lives? Now, one of the aspects of this which is most important is that the human body has developed mechanisms over hundreds of thousands of years to deal with dust, contaminants, pollution, and so on. We've been burning things for hundreds of thousands of years, and the body has developed ways of dealing with that. We have mucous membranes, we can create enzymes and so on. The blood can get rid of a lot of chemicals produced by the products of combustion of natural materials, but it's very different when it comes to modern materials and polymers particularly, and chemicals. The body hasn't yet learned how to deal with those and how to get rid of them in the body, and they can potentially stay in your body for the rest of your life, creating damage to cells, causing cancers, being passed on in genetic defects. So what other factors should we be taking into account when we're choosing materials responsibly? Obviously, topically, combustibility is one of the main aspects that we choose. When we're trying to develop new systems and products at Ashton Lacey, we will take into account a number of factors when we're trying to identify materials. Combustibility is still the number one factor. The first question that we're asked about our systems when designers approach us. But we're also, as we've discussed, very concerned about fibers, nanoparticles, dust, and so on. Is the material polymeric? Is it going to create a microplastics issue? Does it contain a non-mineral, i.e. chemical of some sort, flame retardant? Is the material thermoplastic or is it thermoset? I.e. can it be recycled or is it likely to end up in a landfill? And is it entangled? Have you actually taken two materials which potentially individually could be recycled and created one that can't be? And also, is it all of the above? In the worst case scenario, for instance, if you have something like a nanoparticle reinforced, say graphene, flame retardant, foil face, thermoset, polymer, the chances are that's not going to be a great material from many points of view. Toxicity, combustibility, environmental disposal, microplastics, landfill, and so on. So just a couple of observations. Culture change. Dame Judith Hackett has been imploring us as an industry to drive change, stand up and be leaders, actually improve the culture, take life and safety more seriously than the regulations require us to, and so on. I think this is a waste of time. I think that the industry does not behave as a collective. No matter how much somebody will try to persuade you, there is always going to be some part of the industry who is desperate to win work, put food on the table, and they will cut corners to do so. All industries suffer from corruption. It's a human trait. The car industry with Dieselgate, aerospace industry with satellites falling out of space, and the 787 MAX regulation scandal. What I'm particularly concerned about is avoiding rare catastrophic events. And by definition, it only takes one bad apple to spoil the whole situation for everybody. And it's the people that don't really engage, don't listen, don't join the working groups, don't subscribe to the trade associations. Those are the people that you really need to worry about. And it's also hardwired in our DNA to cheat, and it's been proven scientifically that organisms will cheat if necessary to seek a gain or an advantage. So my advice is to the government and regulators and so on is don't rely on outcomes and culture change. It's a bit of a wishful thinking. We should focus on getting the product classifications, the competency framework and the performance requirements correct and robust, and then develop a rigorous way of regulating that and implementing those regulations effectively. So what we have now is changing regulations, retrospective changes, new guidance, which still is unclear, with flawed classification standards, coupled with increased liabilities, onerous obligations, more powers to judges to apportion liability, all against a backdrop of emerging information on new dangers, new products and new materials. This creates, in my view, a very scary environment for anybody designing buildings moving forward. And my real concern is that this is going to persuade people to look at other industries for their careers. We're trying to improve our industry. We're desperately being encouraged to do so, but we can only do that by attracting new talent into our sector. And my concern is that with a situation like this, where everything looks like the flogging will continue until morale improves, then it's going to be very difficult to attract people into what otherwise is a very positive industry, where it's very easy to motivate people with the amazing buildings that we build from time to time. But I fear that we've created a very onerous environment, the most regulated building and construction industry in the world. And the annoying thing as well is that I think that largely is down to the fact that we didn't spot the dangers in the first place. We didn't ban the materials, we didn't listen to the dangers and so on. And yet I still think those loopholes exist now for more potential disasters moving forward. So a few further points and a few further thoughts on that. As we saw in the pandemic, in my view, scientists had far too much power and control. It's the job of scientists and advisors and so on to give warnings of the dangers, warn the public, and let the public decide what level of risk is tolerable. And that's so often overlooked as we sit in our standards meetings and we set regulations and so on. The key thing that's been said many times is that people shouldn't only be safe, but also should feel safe in the buildings. And when anybody ever says that, I always say, well, the moment you put a combustible material on a building, they've stopped feeling safe. No matter how much you try to persuade them, or you can justify, or you can give them the certificates or the classification reports, if you tell the general public that your building is combustible, they're no longer going to feel safe. As we've been reminded often, compliance will not be enough. So your ability to judge the risks and so on are going to be crucial as you move forward in your career. Warren Buffett's principle of investment is basically to only invest in what you understand. And my attitude is to only build and design with materials that you understand as well. If you're unfortunate enough to be in a situation where you're in court, facing a coroner, inquest or so on, then one of the key things that they will be trying to ascertain is, did you act reasonably? So as you've seen in the Grenfell inquiry, one of the constant lines of questions is, well, yes, those were the regulations, but didn't you know about the fires in Dubai? What about the fire in France? What about the fire in Melbourne in 2014? Weren't you aware of all of these? Because if you were, then following the regulations and the guidelines won't be enough justification for what you did. Did you act reasonably given the knowledge that it was available to you at the time? And the key word to pick out of that type of situation is reasonable. And reasonableness is a key element to acting as a human being and as a responsible designer. And that leads me on to this next word, which probably deserves a presentation all of its own. ALARP, as low as reasonably practicable. If you haven't acted and chosen a material or a product which was clearly safer than the one you chose, yet was freely available, a similar cost, and a reasonable alternative, then you might be in big trouble. The ALARP principle seems to be forgotten in many situations. So even if there's a great motivation to choose a more sustainable material, one with lower embodied content and so on, the guiding principle of chartered engineering, professional engineering, is that safety is paramount. So if you haven't taken the reasonable steps to choose the safer option, regardless of everything else, then again, you potentially will be in trouble. My attitude to risk, whether it's in life, in business, or in design and so on, is that if you have an opportunity to eliminate the risk rather than simply reduce it, then you should take that opportunity to do so. One of the constant aspects of the Grenfell Tower inquiry, and when we talk to academics and researchers and so on, when it's come to look at life safety, I've got a great deal of time for Professor Jose Terrero, but this particular situation reminded me of something which I find unsatisfactory when it comes to regulating. When you draw a stick figure running down a corridor and you're calculating the time it takes them to do so, and you're using that to calculate whether the material on the outside is sufficiently safe enough, it feels like an exam question. But we're not dealing with an exam question here. That stick figure actually could be a friend, a relative, a loved one, a beloved son, daughter, mother, father, maybe incapacitated in some way. The lack of compassion and empathy that seems to prevail throughout these situations always strikes me as odd. The job is to make that situation not happen in the first place. Prevent the fire from happening if you possibly can. As engineers and professionals, we have a responsibility to raise awareness to others around us of any dangers that we might perceive. And my final thought for everybody is to take these choices personally and your role within the business and everything you do. The world is changing. It's a very complicated situation out there. If you don't understand something, go for the simpler option. Go for natural materials, go for things that you understand, but take the responsibility personally.